Hey guys, welcome back. So in the last video we saw how to delete a node from circular double linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm looks like. So the name of the method is deletion of a node. It takes head reference and location from where the node needs to be deleted. Now first of all we do a check. If the linked list does not exist, then we simply return because in that case there is nothing to be deleted. In case the location is 0 and the linked list exists, that is if we want to delete the first element, then what we have to do? We have to first check if this is the only element in the list. In that case there are very simple things to do, that is head.next, that is current node next reference and current node previous reference, both needs to be made null so that we can eliminate the self loop. Then we go to head, make it null, and tail, make it null. So that way nobody will be pointing to node 1 and hence it gets eligible to be deleted by garbage collector. Once all these things are done, we can simply return this method because after that we don't have any other thing to do. Now in case if we want to delete the first node and that is not the only node in the list, then we have to do these steps. What are the steps? Head is equal to head.next. So what is head.next? Head.next is 111. So we are saying that update head and make it 111. What that will do is it will disconnect this connection and establish a new connection between head and node 2. After that, head.previous is equal to tail. Right now head is 111. What is head.previous? It is 001. So we have to update this and make it 333, which is tail. Why we are doing that? So that we can disconnect node 2 and 1 and node 2 becomes the first node which starts pointing to node 4. Once that is done, we have to update tail.next is equal to head. Now what is tail.next? Tail is 333, tail.next is 001. So tail.next we have to update, make it head. Head is 111. So this will disconnect this existing connection and establish a new connection between node 4 and node 2. So now as we can see, node 1 is not being pointed by any of the reference variables. So it can be safely deleted. Now let's say if we want to delete the last node, then what we should do? Then once again we have to first check if this is the only element in the list. If it is, in that case we say head.next and head.previous. Both of this should be set to null so that we can kill the self loop. Once that is done, we make head and tail null so that the current node is not being pointed either by head or tail anymore. Once that is done, the node gets automatically eligible for garbage collection. So after that, garbage collector automatically deletes the node. So we don't have any other thing to do after that, so we simply return. Now in case we want to delete the last node and if it is not the only node in the list, that is if there are other nodes as well in the list, then what we should do? In that case we will update the tail pointer first. So we'll say tail is equal to tail.previous. So right now tail is 333. What is tail.previous? Tail.previous is 222. So we are updating tail and making it tail.previous, that is 222. So disconnection has been disconnected and tail will now start pointing to node 3. Once that is done, we see tail.next is equal to head. So what is tail right now? 222. What is tail dot next? This reference over here. So we have to update this and make it equals to head, which is 0, 0, 1. So this will disconnect this connection and establish a new connection with node 1. Now the last statement is head.previous is equal to tail. So what is head right now? 0, 0, 1. So what is head.previous? 333. Now this needs to be updated and it needs to be equal to tail, which is 222. So this will automatically disconnect this connection and it will establish a new connection between node 1 and node 3. So after all these steps, we see that node 4 is not being pointed by any reference variable anymore. So it gets eligible for garbage collection and system deletes it. Fine. Now let's say if we want to delete a node which is neither the first node or the last node. In that case, how should we do it? So in that case, the control goes to the else block. So let's say if we want to delete node 3. So the control goes to the loop, starts with head and goes till location -1. Now what is location? Location is node 3 that we want to delete. Then what is location -1? The node which is before node 3, which is node 2. So we'll start from node 1, keep traversing towards right until we reach node 2. Once we reach there, we assign the address of node 2 to a temporary variable. So let's say TMP is the temporary variable and it is having address 111, which is the address of node 2. So the first statement is temporary node.next. Now what is TMP node.next? TMP is 111, .next is this reference here. We have to update here. What update? TMP node.next.next. So what is TMP node.next.next? .next is this and .next is this. So we update here, make it 333, which is the address of node 4. So this will disconnect node 2 and 3 and connect node 2 and 4. Now the next step is temp node.next.previous is equal to temp node. So what is temp node right now? 111. So what is temp node.next? 333. What is temp node.next.previous? 222. So this needs to be updated and made 111. So we put 111 here. So this will connect node 4 and node 2 and disconnect node 4 and node 3. So now as we can see, node 3 is not being referenced by any of the reference variable. So it is eligible for garbage collection and system will automatically delete it. So this is how we can delete any node from a given circular double linked list. Hope you have understood the entire algorithm. Now let's see how does the time and space complexity looks like for this algorithm. So checking if the linked list exists or not is a constant time operation. Similarly, if we want to delete the first element or node, in that case we have to update few of the reference variables. So all of them will take constant time operation. Again, if we want to delete the last element, so that will take some reference variables to be updated. So that will be constant time operation. Now if we want to delete any node which is apart from first and last node, then we have to run a loop which starts from head, goes till location -1. Now in the worst case, we might have to travel almost entire linked list. So this will take order of n time. Once we know the location, after that we have to update some of the reference variables which will take constant time. So if we add up all of this time complexity, we end up with order of n complexity. Now the space complexity once again will be order of 1 because we might be using some temporary variables here and there, but nothing proportional to the size of the linked list. Hence the space complexity will be order of 1. So I hope you have understood how the time complexity of deletion works. Now in the next video, let's talk about how to delete the entire circular double linked list. Thanks for your time. See you in the next video.